Our project is on the impact on user contributions based on toxicity and gender dynamics in GitHub project discussions. For our study, we aim to analyze the effects of toxicity on GitHub. Work on open source software is often done by volunteers. GitHub is usually the tool of choice for these developers as it has useful features such as pull requests, issue discussions, and comments. However, as with all online platforms, users sometimes post toxic comments on GitHub. This toxicity can create an unwelcome environment for both current and potential developers. Our goal is to quantitatively study the effects of toxicity on GitHub by analyzing how receiving toxic comments affects developers' contributions to OSS projects. Our research questions are: does receiving destructive criticism or uncivil comments affect a user's contributions to OSS projects? And do the effects of such comments affect male and female contributors differently?
So in this first paper by Miller et al., the authors ran a qualitative study of curated GitHub issue discussions to categorize the types, authors, and triggers of toxicity. They categorized comments into 6 types: insulting, entitled, arrogant, trolling, unprofessional, and other. Insulting comments were those targeted at people rather than the code, and generally aggressive in tone. Entitled comments were those that were demanding in tone, generally for time or quality reasons. Arrogant comments were those where the author exerted a sense of authority or superiority over the target. Trolling comments were sarcastic in tone or non-conducive to the discussion. Unprofessional comments generally were not intended to offend anyone, but still created an unwelcome atmosphere. The charts to the right show the frequency of each type of comment and how often comments fit in multiple categories. Here, a severe comment was defined as one containing curse words. The study also analyzed the authors of toxic comments and categorized them in one of 4 ways. New accounts were those with little prior activity on GitHub and seem to have been created solely to leave toxic comments anonymously. Repeat issue reporters had little or no code contributions on GitHub, but often leave comments on repositories. Project members were those that contributed at all to a project. Experienced contributors were those that had many public commits across GitHub. Table here shows the frequency of the different types of toxic comment authors. The study also categorized the triggers of toxic comments in one of 4 ways. When the OSS tool fails or a user gets an error message, they may post destructive criticism or simply complain without offering additional context. Technical disagreements occur when people debate about which platforms or age of platforms to support or the implementation details of a feature. Comments were said to be triggered by politics or ideology when the author comments on the involvement or lack of involvement of a company based on their beliefs. Comments could also stem from previous interactions with familiar users. This chart shows the relative frequency of the different types, triggers, and authors of toxic comments and how they relate to one another. This paper is relevant to our study primarily because it offers a detailed way to define toxicity in the context of OSS development. This is important because the authors found that toxicity on GitHub is different than on other online platforms. In general, GitHub negativity is more entitled in nature and contains less swearing and hate speech. Knowing this helps inform how we filter the comments that we mine from GitHub. However, this paper only focuses on the qualities of toxicity on GitHub and does not investigate the effects of toxic comments on targets. Our study will address this research gap.
As of second paper, this paper found that only 5.8% of the site's active contributors were female, when female visitors accounted for 20%. Not just in Stack Overflow, females are virtually absent from online programming communities. Females posted more questions compared to males, but did not participate as much. So the authors wanted to find out what they consider as barriers to participation and suggest future design implication to increase diversity and open source communication. As the paper was only interested in finding out what females consider as barriers, the authors only interviewed the female users of various usage level, and they included 1 top-ranked active female users and identified the 14 barriers that the interviewees agreed upon. They were mostly categorized into 3 parts: 1 in which they were not sure how Stack Overflow worked with all the features and everything. Second, they felt uncomfortable joining the community and conversation. And third, in the process of posting, they encountered obstacles that undermined their interest in posting. For additional detail, the table consists all 14 barriers along with its description. To further investigate the significance of the barriers they have collected, they surveyed both genders, in which majority were males, asking to rate the barrier on a scale of 1 to 5. After performing the test, they found a significance of 5 barriers. One, in which it was awareness, they were not sure about all the features. Second, qualification, they felt they were unqualified to answer. Third, intimate community size. Fourth, stranger discomfort, in which they just felt uncomfortable. And fifth, the perception of slacking. These barriers have statistical evidence to say they were seen significantly more problematic by females than by males. This paper is relevant to our research as both studies are rooted in the broader theme of gender inclusivity in open source community, emphasizing the role of community culture and interaction dynamics in shaping participation and contribution rates. While this paper examines the perceived barriers on Stack Overflow, our study extends to investigate GitHub, and instead of identifying our barriers, we would solely focus on toxicity and quantitative measures to measure the impact of community dynamics on gender participation. In terms of a research gap, they identify barriers based on perception and self-reported experiences, so they did not measure the actual behavioral outcomes of these barriers. It lacks a detailed quantitative analysis of how gender-specific barriers influence actual contribution metric. Lastly, exclusively interviewing female participants to identify the barriers make the study introduce selection bias in defining what counts as a barrier.
The next paper is destructive criticism in software code reviews and how it impacts inclusion. This paper directly relates to our topic because it discusses the prevalence of destructive criticism and how it affects inclusion and participation in the software development environment. It goes into detail about the perceived difference in gender differences and how different genders react to destructive criticism differently. This directly relates to GitHub ecosystem of PRs, where an outsider may need to create a PR in order to directly contribute in open source software. The study used an online survey with 93 software developers, including men, women, and small number of non-binary participants. The table shows different demographics of developers, which had gender, occupation, age, experience, among others. The survey included vignette-style questions where participants were given hypothetical scenarios and where they received either constructive or destructive feedback during code reviews. Then they were asked experience questions, which where they reflected on how often they received destructive feedback in real life code reviews. Opinion questions, how they felt about this destructive criticism and its appropriateness. The table on the right gives some examples of questions and their response questions. For the results part, some of the results included that the destructive. Some interviewees noted that destructive criticism was appropriate and felt that their code quality improved after that, but mm, women generally strongly disagreed with destructive criticism being valid. For the other results, the interviewees felt that destructive criticism negatively impacted their performance across the board, including working on that specific task with the specific developer who criticized them and on the project as a whole. The study found that destructive criticism has more negative impact on women than men, where women were reported feeling less motivated to work with developers who gave them such feedback. For the relevance part of the study, this studies the effects of negative feedback on team participation and dynamics, and provides evidence that negative feedback does affect different genders in different ways. The research gap in the study was that it does not study toxic comments on open discussions or conversations, rather studies negative feedback in just code reviews. The study was based on interviews and vignette style questionnaires and does not really study actual comments but the opinions of people on those comments. While the interviews had some questions about future steps, it does not study how the developers decided to whether to continue contributing to the projects or not. We aim to we aim to address this gap because especially in OSS, it is important to see what the effects of such behavior is.
This research paper studies the gender bias in open source software projects by analyzing over 3 million PRs from GitHub between 2010 and 2015. Using a quantitative approach, it compares PR acceptance rates for men and women, linking contributor profiles to gender data via public social media profiles. The study employs statistical methods to evaluate contribution size, context, and acceptance rates, offering insights into systemic biases and their impact on diversity and inclusion in OSS. The study found that the women had an overall acceptance rate of 79.9%, which is higher than men's 74.2%. This suggests that when judged solely on the quality of their contributions, women tend to outperform men, possibly due to the higher effort and expertise required for them to persist in the male dominated open source software environment. This aligns with the survivorship bias, where only the most skilled and determined women remain active in OSS, leading to higher quality contributions. A significant bias was observed in the figure 6, which shows that outside contributors who are not official part of the project and have identified gender cues, such as their name or profile pictures, their acceptance rates dropped by 12% compared to women with gender neutral profiles. This indicates that visible gender triggers unconscious bias, undermining their contributions regardless of quality. Uh, in the next slide, the table 2 provides a detailed breakdown of contribution size across the 50th, 75th, and 90th percentile, measuring lines of code added, removed, and other metrics. The 50th percentile, or the median, reflects the typical contribution size, while the 75th and the 90th percentiles highlight the larger contributions made by the most active contributors. Across all these metrics, women consistently make larger and more complex contributions compared to men. The figure 5 explores differences in pull request acceptance rates across different programming languages and non-programming tasks. Uh, Women show notably higher acceptance rates in programming languages such as Python and Ruby, where their contributions are often well received. However, biases are evident in non-programming tasks such as documentation or configuration or configuring files, where women face comparatively lower acceptance rates. This variance suggests that biases are context dependent. Women are more likely to be judged on their technical skills in programming tasks but are undervalued in areas perceived as less technical, even though those areas are critical to the success of OSS projects. Um, how is this paper relevant to our work? This paper examines the bias and its effect in OSS participation, especially on GitHub, which is our area of interest as well. It also links it to the user behavior in the collaborative environment. The research gap of this research work is that the study did not explore the link between bias and toxicity in user discussions and its impact on the user contributions.
We ended up compiling the main ideas of these 4 papers into a research matrix to systematically identify research gaps that currently exist. In general, the papers tended to veer toward more qualitative research or did not mention the effects of toxicity, which is very important for human understanding but may not be backed up with quantitative metrics. It is our hope with this project to provide quantitative measurements to reinforce the qualitative conclusions of the existing literature.